Number 10. A trolley M collides head-on with trolley L. The mass of trolley M is greater than the mass of trolley L, and the trolleys join together after the collision. We've got to say which statement is correct. So, having read through these, it actually, at first glance, I could see why you could argue, or you could see that just about any of these could be correct, but then we'll have a work out of why 3 of them aren't. So, first of all, the momentum of each trolley is conserved. I think the important point here is each trolley, because obviously momentum is always conserved, but as these two come together, if we look at the momentum of this one and the momentum of this one, before the collision and after the collision, each individual trolley is going to have a different amount of momentum, so that one's not going to be true. Trolley M experiences a greater force than trolley L during the collision. You might be tempted to think that's correct because trolley M's got a bigger mass, but Newton's third law tells us that when two bodies are interacting, the forces they exert on each other are equal in magnitude and opposite in direction, so B isn't correct. And finally D, kinetic energy is conserved. Well, in this one you need to realise, because it's telling us that the trolleys are joining together, that means that is going to be an inelastic collision. And whilst energy is always conserved, only in an elastic collision is the kinetic energy conserved as kinetic energy. So that leaves us finally with C. The total force acting on the two trolley system during the collision is 0. And the reason for that is, yes, whilst trolley M, well, it's changing its momentum, so it will have a resultant force acting on it, and the same is true of L, but because of Newton's third law, if we look at this as a whole system, this force is pushing this way, and let's draw that in, and then this one's pushing that one that way, then these two forces are going to cancel out if we look at the system as a whole. So the answer is C.